Everything clear with deadlines, how things work with submissions, etc.? Cool. Okay, so today my plan is to talk about different terms, how we describe different types of maps. We will talk about some key terminology, learn a little bit of history of maps, and then also we will get a little bit of practice with creating different types of thematic maps in ArcGIS Online. I'm gonna make extra sure that my Teams is working here. Looks like it is. All right, so to get us all excited on this Tuesday morning, quick little intro video with some cool maps from Esri. This web address is a great place to go check out really cool maps for inspiration. It's actually where I got the example we'll take a look at later today in lecture. So what is a map, right? This course is not only based on using GIS, but also the field of cartography. And maps have been around a long time, as we'll learn about today. I need to ask my department for like funding to get a coffee station in here because this class is so early. But I appreciate you all who are here and tuning in online as well. All right, so what is a map? We had this example of mental maps where we sketched our mental map of Bozeman. It really depends on our own experience, right? Landmark knowledge, route knowledge that we may have developed over the years of living here. You might also expect that people who have been here for a longer period of time just have maybe a richer mental map library to work with. We will also talk about the example in the middle here, which is a general purpose or a reference map. And finally, we will also, we'll talk about another type called a thematic map. And then we will also talk about dynamic maps today. Where is my laser pointer? Go. So maps are representations of the world, right? That definition really leaves a lot of room for interpretation. We have maps that are very faithful to the real world, even digital reality capture devices, like maybe you've seen those three-dimensional tours of the inside of people's homes. As our technology improves, the level of realism and detail that we can achieve also improves. But we don't always want the most detailed map. That's not always going to give us the best solution for what we are trying to convey with our mapping work. So maps can be mental, physical, or digital. They use a scale, a projection, a coordinate system, and symbology to transform things, natural phenomena, things that occur on Earth or other planets, to a diagrammatic visualization of those features. And hopefully that visualization is very easy to read and intuitive for your audience. So that's really the field of cartography, right? What are the choices that we make in these four categories here, and how does that affect how our map looks and how it's perceived by the audience? So three major types: reference maps, thematic maps, and dynamic maps. You can also have maps that layer on top of each other, maps that actually fit into these different categories. All right, so let's do a little bit of history. The earliest speculated map, or essentially people debate whether this should be considered a map or not, but it looks kind of map-like to me, is actually dating to about 25,000 years BCE. found in the Czech Republic. And what it is a mammoth tusk with symbols carved on it that appear to be plots of land, maybe agricultural, looks like some roads here. So maps, as we understand the history, probably date back, 27,000 years. The oldest sort of confirmed and agreed upon map is actually called the Babylonian Imago Mundi, dating to about 600 BCE. And this map, as we can see, is inscribed on stone. It has some writing here, but it's sort of a graphical representation of a city. We have some roads, and then we have some roads actually radiating out from it and cut sort of a star pattern, showing you which direction you would head to get to various different locations. So this could be considered a general purpose or a reference map. So the earliest maps were reference maps, right? Makes sense. What you'd probably want to start mapping is locations of features. The users of these maps might have different reasons for looking at them, but it serves a general purpose. You could say, where is Asia with respect to Europe? What are the relative sizes, etc. In medieval times, around the 7th century, it was very common to see in books and other writing what is referred to as the TO map, because its shape was essentially a T inside a larger O. And this rarely represents what people's view of the world was at this time. 3 major continents, Asia, Africa, and Europe, separated by seas or land boundaries or mountain ranges, and surrounded by a vast ocean. Also, very little understanding of the fact that you can keep going in one direction and actually wrap around the Earth. Around the same time, we saw some gradual improvement in the 900s. There was someone named Al-Mansur who was the second Abbasid Caliph and the founder of the city of Baghdad, which we all know in modern times, of course. This map actually had a projection associated with it, and the land masses were scaled much more similarly to their actual sizes and shapes. So in terms of who was making the best maps, around this time, 700 to 900, probably coming out of the Middle East, and this is a great example. Like, there are actually some recognizable features on this map, right? Saudi Arabia down here, Europe here, Asia over in the top right. Understanding of the Southern Hemisphere sort of understandably lacked some detail at that time. In the 1300s, European maps started to catch up a little bit, and they really focused on ship navigation. So this example is called the Portolan map. Notice the word port in there. And the goal was to map the compass bearings you would need to follow if you were on a ship to navigate from one port to another. So it often had straight lines drawn on here. And essentially, if you were at one port, you could use this chart to figure out which direction you needed to head to get to another port. So who can tell me, is the fastest way to get between 2 locations on Earth a straight line on a map following a constant compass bearing? Yeah, you're saying no. Do you know why that is? Yeah, exactly. Because of the 3-dimensional nature of the Earth, it's actually faster, especially if you're north or south of the equator, to follow a curved line called a loxodrome. I would write it out, but it's hard to write with my mouse here. I'll spell it on a subsequent slide, but it's essentially a great circle path. If you've ever taken an overseas trip on an airplane, you probably noticed in the northern hemisphere you went way up north. Like if you were going to fly over to Europe from maybe San Francisco, you would fly up over Canada and actually almost reach the Arctic Circle before going to Europe. So This really does reflect the navigational tools that were available at the time, and the understanding of how to actually navigate. It was much easier on a boat to just continue following a constant compass bearing rather than attempting to change your compass bearing based on your distance. And mainly that was because it was hard to calculate the distance you had traveled in a ship, right? Much easier to just point it straight and keep going. All right, a map out of Germany, the Waldseemüller map in 1507 was the first map to depict the Americas as separate continents, and actually is largely responsible for the name America, which was in honor of Amerigo Vespucci, an Italian navigator. So this German map, we can start to see recognizable continents as expected, right? The continent of Europe was the best understood and looks the most realistic based on what we know now. Actually, somewhat accurately shows the relative sizes of Africa and Europe. You will commonly see in another German map called the Mercator map, Europe is actually artificially larger than Africa. So this is something we'll talk about in subsequent lectures, but our choices really can affect how people perceive maps. So these relative sizes are actually pretty good, but of course, very little understanding of the geography of North and South America. Any questions or comments? Okay. So I just gave you some examples of reference maps and their history. Of course, we are making them constantly. People are flying drones to get really good high-resolution imagery. That could also be considered a reference map. So these are the family of maps that are used to locate features on the surface of the Earth or navigate between them. The geographic features on the map tend to be treated and represented equally, so there's no weighting to the different layers. You can achieve weighting with cartography by maybe having a more vibrant color for one layer and kind of having subdued color shades for base layers, trying to highlight one data set, give it a bigger importance relative to others. But on a reference map, that's not the case, right? There's no one layer on the map that is more important, right? The highways layer is not going to be more prominent than the railroads layer. And the accuracy is a big thing with reference maps. So in the United States, we have national standards for accuracy for all of our government agencies that are actually involved in creating and maintaining reference maps. These are called the National Map Accuracy Standards. And that really will affect, if you're working on these maps, what kind of instrumentation you need to use to basically achieve the right precision level. So depending on your map scale, you might need a GPS receiver that is much better than your cell phone to create maps that could be used for government publications. So local governments create and maintain these. They need accurate reference maps for land use, zoning, tax purposes, right? If you're a property owner, part of your tax bill is exactly how much land you own. So you need a really accurate reference map so you can figure out the square footage of your property and all those sort of details. National governments, of course, need reference maps for various different purposes. So one good example is U.S. Geological Survey topographic maps. For a long time, these were actually made by hand. What would happen is that an airplane would fly over a region and capture stereo photos, meaning cameras that were kind of arranged like our eyeballs next to each other. And what you could do is use the depth of focus from those stereo images to precisely capture the elevations relative to some benchmark, like the height at which the airplane was flying when it captured the images. And then people would go through and use these contours to actually map out the different elevations. They would use shading to show whether the landscape was covered in trees or grasslands or maybe even something like a talus slope. Mark in roads with different symbologies based on the type of road, and map out development with various different color schemes. So this is the topographic map of Boulder, Colorado. Anyone here from Boulder? All right, cool. I went down to Denver for the Broncos game on Sunday, and it was really fun, but we lost. But it was good to see Colorado. So yeah, nothing on this map is really a primary layer, right? I mean, you could argue that the red is pretty visible on the map, but there's nothing here that is saying like, hey, look at the city, don't look at the forest. You could use this for any sort of purpose you would like. In terms of national governments, you know, the United States of America has a National Geospatial Intelligence Agency, and they are primarily concerned with geographic intelligence. So, for example, lots of different layers are maintained by this agency, and questions like where am I, where are the friendlies, where are the enemies could be asked. Things that are really important to the situation include maps showing the weather, intelligence reports showing where features have moved to or where they're located at any given time, etc. So you can be a super spy with your mapping work, right? Lots of government jobs doing this sort of geospatial intelligence work. All right, so we've covered reference maps. Any questions on those? Cool, so now let's dive into thematic maps. Thematic maps, I think, are the most fun because you have a lot of freedom to display data sets in different ways. There's lots of interesting cartographic techniques you can employ for creating thematic maps. But remember that often the base layer of the thematic map is actually a reference map. So you can have a reference layer inside a thematic map. So these are concerned with a particular topic or theme. They are usually more concerned with how things that fall into this topic are distributed across space. You can actually map things that might be invisible on the Earth's surface, right? You can't walk around and observe median household income. I mean, you might be able to infer that based on certain observations, but like there's no labels on people's houses with various census and demographic data, right? Visualizing these with a thematic map is much easier. Whereas for a reference map, actually being there on the ground and observing is the most accurate representation of those features possible. So they're not mutually exclusive, right? They can be overlaid on top of each other. And we've talked about what overlaying is. It's just stacking layers up and using different symbology schemes to make sure that you can actually interpret multiple map layers at once. We talked about this example, the snow cholera map in 1854, one of the early examples of a thematic map. Just to drive home that point I was making earlier, right? You couldn't necessarily walk around and visualize on the Earth how many cases were located at certain places along Broad Street in particular. But this thematic mapping approach, where the case counts were actually shown with a bar chart visualization, was able to achieve that, and is a good example of thematic mapping. Another very famous example, a little bit more abstract here, is a map of Napoleon's march to Moscow. Spelled wrong, sorry. Anyone studying history in the room? Cool. I always loved history. I thought I was gonna be a history major when I went to college, and then I took courses in geology and switched over. But history is awesome. Geology is just like really, really long history with some physics thrown in. So this map shows in sort of it is a map, right? Because it has the relative positions of various features, starting with a river on the eastern boundary of, what river is this? The Niemen River, going all the way to Moscow on the northeast side. It does have a coordinate system and a reference frame. North is up on this map, but it uses a clever cartographic technique called a flow map to chart where Napoleon's armies went and also their size through time. So this really tells the tragic tale of Napoleon's army just being completely decimated in the Russian winter, trying to capture Moscow. Similar story, of course, played out in World War II with the German armies. So starting at first, when the invasion was launched, right, the size of the army was represented by the width of this box. about 422,000 soldiers, a few diverted northwards here, a few more diverted northwards and rejoined the military over here, but then eventually a lot of people left. The story was of disease and bad weather. So you can see how the army was reduced in size as it marched to Moscow, where eventually it was defeated, turned around and started retreating. And on the bottom here, we have a diagram showing the temperature with 0 degrees Fahrenheit at the top and -30. So, sorry, that's Celsius actually. 0 Celsius at the top and -30 at the bottom, showing the temperature during the retreat, which obviously explains why there was so much more attrition and fatalities as the army retreated. So pretty striking to see that visualization of the massive width of the army, the massive size of the army at the start, reduced all the way down to 10,000 soldiers at the very end. Did not go well. More modern example here. Lots of really cool thematic maps are out there, but here's one I like. It uses sort of a firefly visualization, which is sort of like a heat map. And what it does is it shows hotspots of piracy in both the Indian Ocean and the southeastern Atlantic Ocean and the Mediterranean. So geographic regions here are divided into boxes, and then the number of incidents of piracy are actually highlighted with these bright sort of warm colors, which give you the sense that these areas are truly hotspots, right? They're lighting up on the map. The cartographer also chose to use kind of subdued colors, dark colors for the reference layer, which gives you that visual hierarchy, right, of the thematic layer really jumping out at you and the reference layer just kind of fading into the background. It's important, you have to have it there, but you don't want it to take up too much attention relative to the thematic layer. And this is an example of how thematic maps are often focused on the distribution of things across space and that principle of hierarchy. All right, so we talked about reference maps and thematic maps. Let's talk a little bit about dynamic maps as well. So these are interactive and changeable. We are probably all familiar with dynamic maps. Both reference and thematic maps can be dynamic in nature. It just depends on how they are distributed, right? If they are on a website or a web application that you can install on your phone, it's probably dynamic. Whereas if it's distributed as a PDF or even a printed piece of paper in a book or on the wall, that would be not a dynamic map. I would refer to that as a static map or a physical map. So tons of people have access to such maps. Really important to make sure that the people making the maps have some training in cartography so that the points that are trying to be communicated by the map are actually communicated and maps are not used in a misleading fashion. There's a great book called How to Lie with Maps. And if you're really into cartography and how the history of how people have manipulated mapping to actually tell their side of the story, it's a really good one to check out. One common example is political parties will visualize election data in very different ways to tell different stories. For example, rural areas tend to lean towards the Republican side of our party system, right? So if you are a Republican and you want to emphasize how much of the country votes Republican, you might choose to just fill in geographic areas with the color of the party that they voted for, right? Whereas if you're a Democrat, you might emphasize the number of people because typically higher population cities, places along the coast where the population density is high, those tend to vote more Democratic. So depending on what story you want to tell, you can choose different mapping techniques to sort of influence how the person reading the map actually perceives that map. All right, so we all know some examples. Cool one from a company that actually has offices locally and periodically puts out job advertisements is Onyx Maps. You may have used this yourself. They actually started just compiling land ownership data and selling SD cards you could stick into your GPS receiver. That's how they got their start. So just kind of taking the work out of finding that geographic data and putting it on a flash drive, you stick it into your device and you go hunting. Now, of course, it is a full mobile application. You can actually consider this to be a type of GPS, right, or GIS, because you can map features. You can map things like where did you park your car, where did you actually see some animals, etc. And they've also launched other applications for other uses like backcountry, trail running purposes. Anyone here doing the rut this weekend? All right, cool. So all the maps on the RUT's website are based with OnX, and they do a good job at 3D visualization. I'm not running the RUT. I'm more of a cyclist myself. But good luck if you're running the RUT. We talked about this, layering, very important for thematic maps. All right, so let's actually analyze a map. I'm going to open this up on the screen here, and I'm also going to paste this link in the Teams channel as well. I should have done that before class. I apologize. So if you got Teams running on your machine, you can go ahead and check this out. This is just a map I found yesterday by going to that URL that was in that intro video I showed. And I think this map is really interesting. We talked about how election maps can be manipulated to show different things. So first of all, what is this visualization strategy here? This is actually a dot density map. And it's using what is called dasymetric dot density. And honestly, I was thinking to myself on my way into lecture today, I need to look up what that actually means. So here we go. It's a type of thematic map that uses aerial symbols to visualize geographic fields by refining a choropleth map with ancillary information about the distribution of the variable. All right, so what that translates to is that, snap is right. It's dot density, but the position of the dots is controlled by a boundary, which in this case, I believe is census block groups, which is the most detailed level of the census geographies. So those block groups are actually polygons, and the dots are being randomly placed inside the map. So before I analyze this map too much further, what I want you to do is let's take like 3 minutes and answer these questions for yourself in your notes. What are the reference layers in this map? What are the thematic layers? What type is the thematic layer? What is the data structure? We've talked about these ideas of features and surfaces. And then what do you like about the design? And what, if anything, do you not like about the design? So ready, go. And then after that time period has elapsed, I will ask you to discuss your answers with the person next to you. Let me pull it up here. So it doesn't really like me zooming around too much here, so I'm going to just leave it at the max zoom level. So if you have finished up those questions, feel free to start discussing if you'd like. All right, if you're not discussing yet, I would encourage you to turn to the person next to you, introduce yourself if you don't know them, and just run through your answers real quick, see if there were any differences, and discuss what you liked and you disliked about this map. Okay, so how could we describe the reference layer here? Anyone? Yes. Cool. So yes, you can click on actual geographic layers, bring up a little bit more information there, right? But at its most basic level, it's the outline of the conterminous United States. Um, just something that I noticed here that maybe you didn't notice yet or didn't understand yet because we haven't dealt with it is the curved border with Canada indicates this is a projection that is a conic projection. Means it's kind of projecting the Earth onto a cone shape. You can kind of see those lines of longitude converging towards the north. I like that choice, but that's part of building your reference layers is choosing which projection. I like it because it looks a little bit more realistic in terms of if you were looking at the Earth from space. But a lot of people are used to seeing that border with Canada as a straight line. So some users might be a little bit thrown off by this projection. Just really kind of depends on your experience. And if you were to zoom in here, I think different layers turn on with different geography details. So you can actually probably see the boundaries between various places. Because mine was crashing, I'm not going to zoom in on that layer. And just notice how it's a gray, lightly shaded line with a white background. Really not trying to distract from the thematic layers on this map. So what are the thematic layers? They're, of course, the vote counts. And this map is pretty ambitious because it tried to use one dot for every single vote in the 2016 election. So that is probably part of the reason why when I zoom in, my browser is actually crashing, right? It's a really robust data set. That's part of your design choice as well. Do you want that much data? Do you want to make it hard for the computer to actually work with the data? Here, it seems like this cartographer was really trying to get the best representation of the data possible and trying to make it as fair as possible to really see where the votes are actually located. So one dot, a red dot represents a Republican vote and a blue dot represents a Democrat vote. But another way we could make this map a little simpler and maybe help with the visualization is have a scale factor there. You could say one dot is 10 votes for both parties. and it would be a little bit simplified. So if you look at different areas of the map, right over here in the New England area, you can obviously see that there's lots of Democratic voters there. Small pockets where you see some red coming through, but overall it's almost entirely solid blue. But that's a problem. You can't really see how many dots are there because the dots are just all over each other. There's not enough room for them to plot. So when you're creating a dot density map like this, what you want to do is choose a dot size where in the highest density of data, the dots just start to intersect each other. But if you choose a 1-to-1 factor, that might be impossible depending on your zoom level. One thing the cartographer did here is that he limited, I think it's Kenneth Field, limited the zoom level. Just said, hey, you can't zoom in past 1 to 500,000. And that was because they had some concerns about people misinterpreting the map. Obviously, this is someone who does cartography and really understands these concepts, because if you zoomed in too far, you would end up with vast areas of land where you couldn't see any symbols. And also, you might imply false precision for the placement of the points. I mentioned how this is a dasymetric map. There was a relatively complex technique employed to actually place these dots. And it was not just based on the census block groups. Essentially, it used, the description is in here, but basically used the National Land Cover Database and census geographies that classified dense urban, and rural communities to, in tandem, actually place those dots. But the actual location does not correspond to a place where a person lives or voted or works or anything like that. It's just a random placement within those geographical areas. So what did people like about this map? Well, raise your hand if you generally liked it at all. I kind of like it. It's a pretty cool example. I think it's better than the typical election map where it's just a state filled in with a color. Any other observations about why this was a cool map? Separated, you can actually break it down into counties. You can zoom in or out, right, depending on the level of detail you want to see. I really like how you can see the highways, stretching across the nation too. That's kind of cool, especially in the Midwest. You can actually get a sense for what parts of the country are actually populated versus others. Gives you a sense for the density of settlements on the eastern half of the US relative to the west half. Also makes you appreciate the vast size of LA County and the number of Democratic voters who live there. They're often kind of an afterthought, in the election coverage, because they tend to always vote the same way, and the voting closes really late at night. Anything you didn't like about this map? Yes. Yeah, it's I can't even really make out where Montana is, even though I am very familiar with that. I'd have to zoom in. Let's see if I can crash it again. I like how those labels pop up when you zoom into a certain level. You can configure this in ArcGIS Online.